Swayam Prabha. Digital India. Educated India.
Welcome back. So in previous lecture we were talking about the internal and external processes and some information about the cyclone. Now coming to the atmospheric disturbance and related hazard, this is an important portion where we have been experiencing the cyclones every year, and during the month of like during this monsoon season we experience the most. So last couple of years back there was a severe cyclone Verda, which originated again in the eastern part of the Indian Ocean and then moved towards the Indian mainland, and the landfall was in along the southern eastern coast of South India. Similarly, we had very recently another cyclone Gaza, and this picture which you see is the cloud cover and the eye which has been developed here at the center is of cyclone Gaza, which was again a devastating event, but Verda was more intense as compared to this. So usually the tropical cyclone are very intense, and it is because of the intense low pressure areas in the atmosphere over tropical and subtropical waters. Now one of the most important point which you should remember is the direction of circulation, that how the circulation will take place when these cyclones are been formed or developed. Is one is the circulation is anti-clockwise. That is what you can remember. It's anti-clockwise in the northern hemisphere. So if you divide the globe in southern and northern hemisphere, then the anti-clockwise you will observe the circulation in the northern hemisphere and the clockwise in the southern hemisphere, and this is due to the Coriolis effect. So this is one of the important point which you should remember. Now in India, the Indian Meteorological Department is one of the agencies which usually issue the warning to different states which are going to be affected at the area which are going to be affected during the cyclone, and mainly at the time of the landfall. Nevertheless, they also keep informing that what will be the speed of winds and which are the areas are going to be affected over the time, from the time when there is the low pressure start developing. And they have different categories which are been shown, that is in terms of the classes. And if you look at the type of disturbance, what they will give as an information is the low pressure, and then what will be the wind speed, kilometer per hour, and in knots also. And then what will be the type of disturbance? That will be depression, deep depression, cyclonic storm, severe cyclonic storm, or super cyclonic storm. This is helpful in gauging that what will be the amount of damage or the risk we are going to have from a particular cyclone. So mostly what happens is that we have learned until now that most of the cyclones will develop in this portion here, and then they will move on towards west. Okay, so development of the cyclone over here, and then slowly it will move over that. So if you see the previous data, you will find these different tracks which will be shown, and then that will be also marked by the landfalls. It is not only in this area, but also over here you will find the development of the cyclones which are moving towards Gujarat or towards Maharashtra and all that, and in the Karnataka and Kerala side. So this Gaza again had originated here in the eastern southeastern portion of the Indian subcontinent and moved towards the east coast of the Indian mainland. So cyclone Gaza developed over southeast Bay of Bengal, or you can say the part of the Indian Ocean, in the afternoon of 13 November 2018, moved westward or towards east coast of India. Heavy to very heavy rainfall and the wind speed was very high, which affected the areas like Chennai, Kanchipuram and Tiruvallur when it makes the landfall on 16th. So it started on 13th and the landfall was on 16th. So its journey between 13th to 16th was also been given as a warning and it was been updated day to day basis. So wind speed was around 130 kilometers per hour, okay, and it killed around 46 people in Tamil Nadu and Andhra Pradesh. So this was the conditions where when it made the landfall, many trees were been uprooted, electricity lines were been disturbed, and of course it also resulted into flooding. Okay. So this the cyclonic effects are twofold. Usually we have a very high wind speed and which will affect the other utilities, but at the same time you have the issues with the heavy rainfall in the region. This is another picture of taken from based on the satellite data, which shows the eye or the development of the Gaza. It not only affected the areas along the east coast of the mainland, but also some part of the other countries adjoining Indian Ocean in the eastern side. So as I was talking about in one of the slides, that you will find some very typical track along which this cyclone has moved, okay, and the notations which are been given here, like TD, CS, SCS, are been given here as in D depression, DD is deep depression, then cyclonic storm, and then severe cyclonic storm. Okay, so at places you will find that while it is traveling from its origin, the cyclone will get strengthened more and more, and then in between you will have somewhere before the landfall at the time of the landfall, you will find that the cyclone has become very severe. Okay, so that part is very much important. So this data shows that how the cyclone developed and was strengthened up, and in which portion during its journey it became very severe. Okay, so severe cyclonic storm, which has been shown here. So this is a warning which was, or the bulletin which was been issued by Indian Meteorological Department or System Sciences Organization, Ministry of Earth Sciences, which talks about the location and that is your time and date and the location. There's a lat long coordinates are been given, and at that particular coordinate and time what will be the wind speed which is expected in that region, and what is the category of cyclonic disturbance. Either it will be cyclonic storm or a severe cyclonic storm. It will be these warnings or the bulletins are regularly issued. So this was of 13th November. At the same time, along with that, the other information which have been given, and this table shows the information of heavy rainfall warnings which were been issued from 14th to 16th, and 15th, which has been shown by red box. Okay, it says in Tamil Nadu, rainfall at most places with heavy to very heavy, at a few places, and extremely heavy fall which will be greater than 20 centimeter at isolated places, very likely over North Tamil Nadu and adjoining districts of south coastal Tamil Nadu and rainfall at most places with heavy to very heavy fall at isolated places, very likely over remaining parts of the South Tamil. So, this type of informations which are been given are very useful to local people, not only at the land on staying on the land, but also for the fishermen who tends to move for their day-to-day activities. Now, this part of information is extremely important for the state officers to plan the evacuation, because a lot of people who are staying along the coast are mostly the fishermen, and so they need to be evacuated. And of course, if we understand that what will be, how far it is going to enter, that is the landfall, and how much area inland from the coast will be affected, depending on that one can go for the evacuation. Then there is again a piece of information which has been given, that what will be the wind conditions and sea condition, as well as the storm surge along the coastal areas. This information is also provided. So, this is just that how it has been developed over the time. So, it started here somewhere in the southern part of the Andaman and Nicobar Islands, and it moved further, affecting some part over here in Myanmar, and then moved and had a downfall over here. And the one important part is that it crossed the southern tip of the mainland India and went towards the other side of the coast. Okay. Now, another important topic what we are going to discuss here is, in brief, of course, we will discuss in detail later on, is related to earthquake. Now, this is an example of an Kaikoura earthquake which occurred in 2016. The magnitude was 7.8. Okay. So, the information which is shown here is extremely important in terms of the hazard assessment. One is the magnitude, second is what depth the earthquake has occurred, and then the rupture length. So, the depth was quite close to the surface, only 22 kilometers. Of course, 22 kilometers for us is a quite large distance, but in terms of the depth, 22 kilometers for an earthquake, and the energy to reach to the surface is quite less. And if a shallow earthquake like this is experienced in India, in Himalaya, it's going to result into like severe damage to the Indo-Gangetic plain. So, it was like 22 kilometers depth, 70 kilometer of rupture, out of which 36 kilometer was on land, that is what they show here somewhere, and then about 34 kilometer was under the sea, because the fault line or the feature along which this earthquake took place extended on land as well as in ocean, okay, submarine. And similar event was experienced recently in Palu, that is Indonesia, which also resulted into strong ground shaking as well as tsunami. So, the epicenter was near Kaikoura, and this was because of this tectonic setting. I am not getting into the detail right now of this, that is subduction zone, but we will talk when we are discussing about the plate tectonics part. Okay. You will understand more in detail, but this feature on the earth globe clearly shows that there is some unusual things which are happening here, where one plate from this side is subducting below the another one here, and the strain which was developed because of this subduction where one plate is pushing itself down below the another one, the strain which developed was released, that is sudden release of the strain resulted into earthquake. Strong ground shaking was experienced. So this is Pacific plate and this is Australian one. Okay. So the Pacific plate is subducting below the Australian plate, or you can say the Australian plate is riding over the Pacific plate. So this the plates which are subducting or overriding, so between these two plates, usually they don't pass through very smoothly. They have a lot of friction which develops between both of them, which result into the development of strain, and sudden release of the energy stored along this plate boundaries results into earthquake. So if you look at the background here, as I explained, that we have like Pacific plate which is subducting below the Australian plate here. This is what is the whole mass is the Australian plate, and this one is the Pacific plate, and the rupture which was experienced or the energy which was released along the fault line is, you are having one of the active fault line is the alpine fault line. So the damage which was experienced was extensive. You can see not only the structures or the civil structures or houses or the buildings collapsed, but along with that there was huge deformation which was experienced or was seen on the surface. Okay, that is what we call ground deformation. So this is one of the example which has been shown here. The land has moved apart, and also one side of the land has moved down. So this was the pattern of damage. And another feature which you see in this photograph, particularly what we call the land subsidence, resulted because of liquefaction. So this all like things we will discuss in detail, particularly about the land subsidence, liquefaction, and the rupture areas and all that. So this was a deformation pattern which was been experienced or recorded at the time of the earthquake, where you can see the rail track has been zigzagged, okay, or deformed because of surface rupture. The surface rupture runs here, the another part of that runs here. So if you need to make out the sense of movement, then what you can see is this part has moved like that, and this one is like that. Okay, and this again, that was not enough. Okay, like this is another example which shows how the earthquakes can modify the complete landscape at the Earth's surface. This wall which you see here never existed before. This came up at the time of earthquake. So this is what we call surface rupture.
We're standing here in the Papatea Fault, a few kilometres south of the Clarence River Bridge on the Kaikoura coast. Looking here at the fault plane, the plane of movement along the fault itself, where this side here has moved up by about 1.5 metres, and we can see the gravels here and the gravels on that side. But what's really interesting is that we can see lines of movement here on this fault plane which are moving down a little bit in this fashion. And that means we can see, it looks impressive that we're standing here 1.5 metres high, but in fact most of the movement has been along a plane something like this. So this side here has moved forwards by many, many metres. These fault scarps form very, very quickly, and we know from earthquake physics that probably this fault scarp ruptured across here at a speed of about 3 kilometres a second. So this has uplifted a very large area of new reef here, and the locals here describe not the earthquake noise, but the noise of water running off the top of this uplifted platform here. They said that the noise was just horrendous. And on this side, on the downthrown side of the fault, it's actually still even come up by about 1.5 metres. On the other side, there's as much as 6 metres of uplift. Which are moving down.
So this was a very important video where Kelvin is trying to explain that how the movement took place. One can easily look at that what was the height variation or the difference between these two this place, almost like 2 meters or so. So this is what we call as the surface rupture, and what he was trying to explain here was that there was some indication or the striations which developed on the fault plane which was exposed, and it shows a particular direction. Okay, so some striations were been observed like that. So this also talks about or tells us about that what was the direction of movement. So this portion it moved up like that. Now this type of fault scarps or the land level changes occurs mostly at the time of big earthquakes above 7.5 and so, which will definitely result into the landscape change, and that what was been explained here, where he was talking about that new reefs were developed. Okay, like this is one example of that what he was showing.
3 kilometres a second. So this has uplifted a very large area of new reef here.
So he is talking about that this whole area got uplifted and this will form a new reef, coral reef in this region. Now we have another similar video, but that is on land, which we have will try to show you.
We're standing here.
So this the deformation which moved or we can see on the surface, and that was close to the coast. This is on land. Okay. So you can see this rupture, and there was an UAV which was been flown over this, and they recorded a very good deformational feature which we would like to show you. I am sorry there is no sound for this video, but you can easily make out and look at the deformation which was recorded by the 2016 Kaikoura earthquake, and the rupture length was recorded up to 30 kilometers. Usually mapping of such features are extremely important, because this type of features, what we call the fault scarps or the signatures of past earthquake preserved on Earth's surface, will be important for future seismic hazard assessment, or we can say earthquake hazard assessment, because that is going to tell us the complete history, or we will be able to do the reconstruction of the past earthquakes in such areas. So In particularly, if I talk about the Himalayan region, we are trying to map similar features where the earthquakes which occurred in the past have left their signatures, and we are trying our best to evaluate and trying to reconstruct the history of the past earthquakes from such features. So, geological hazards, mainly we have seen some example of earthquakes, and then we have tsunamis. Okay. So, if you look at this very devastating earthquake was been experienced in Japan, and this was in 1995. I'll stop here and we'll continue in the next lecture. Thank you so much.